Hello everyone, my name is Alan Samuel, physics math teacher, and today I'm going to be taking you through mathematics, and today we shall look at vectors. That is our theme today. We are going to look at vectors, but that is for advanced level, not that what you had in O level. So when we talk about issues about vectors, we know under vectors we can discuss about lines, and we know lines are in 3 dimensions. Also can discuss about planes. So I'm going to deal mostly today about planes and lines. So we can be asked a question to relate between a line and then a plane. As we know very well, the equation of a straight line in its Cartesian form or in its vector form. And then also talking about a plane in its vector or the Cartesian form. Now tonight, we want to look at the similarity or to look at something in common. We can be asked, we are preparing you candidates for your neighbor. And then a question comes. They say that show, I want you to quote it very well. Show, because I will not write the whole question. Show that the line x minus 2 over 2 equal y minus 2 over negative 1 equal z minus 3 over 3 and a plane r dot 4 negative 1 negative 3, this equals 4 are parallel. That show that this line and this plane are parallel. Hence, find the distance between a line and a plane. So how can you find or show that these two are parallel, and then also finding the distance between this line and this plane? This is what you must know. For a better student to pass this question, we are going to sketch the two. I will start by sketching our plane. So this is our plane with it is normal, and the normal to this is 4 negative 1 negative 3. This is the normal. Then this is our line. So this is our plane. They are saying show that they are parallel. So that means I have to sketch a line in that level. Then I will say x minus 2 over 2 equals y minus 2 over negative 1 equals z minus 3 over 3. So for me to show that these two are parallel, I will examine out that if this is the normal, it is going to meet this line at 90 degrees. So if I can be able to show that the normal of this plane and the direction to this line are orthogonal, therefore it shows that these two are parallel. How will I show that they are orthogonal? If I dot the normal with the direction of this line and I get a 0, it will therefore show that these two are parallel. So what is the normal? We have seen that the normal is 4 negative 1 negative 3, and then what is the direction to this line? Since it is in its Cartesian form, the direction is 2 negative 1 and 3. So I'm going to dot the 2. If I come back with a 0, it therefore shows that these two are parallel. So I will say the normal, dot it with the direction, must give me a 0. Our normal is 4 negative 1 negative 3. I dot it with a 2 negative 1 and a 3. This should give me a 0. How? 4 times 2, I get 8. Then plus negative 1 times negative 1, you get a positive 1. Then negative 1, so negative 3 times the 3, I get negative 9, which must give me 0. Now when you add 8 plus 1, you get 9 minus 9, which gives you 0, implying that 0 equals to 0. Therefore, these two are pair. Because the question had said, show that these two are pair, and hence find the distance between this line and the plane. Now this is our plane, this is our line. We want to see the distance between the two. But remember, we are going to do this very simple. We are going to consider a point where this line passes. And this point where this line passes is 2, 2, and 3. Then we are also going to consider this is our plane. So when we say the distance between a plane and a line is always given as, so we shall say the distance L, I will call it L, is equal to magnitude of AX plus BY plus CZ plus a constant D over square root of A square plus B square plus C square, where A, B, C is the normal to the plane, and X, B, X, Y, and Z is the point where the line passes through. So since we have already got our point where the line passes through as 2, 2, 3, then it becomes very easy by saying thereafter L is magnitude of our A, we have seen it is a 4, multiply by X, which is a 2, plus our B, which is a negative 1, multiply with our Y, which is a 2, plus our C is negative 3, multiply with a 3. But remember, everything is under a square root of A square, which is 4 square, that is 16, plus 1 square, which is 1, plus 3 square, which is 9. Then we start. That is 8. 8 minus 2, that is 6. 6 minus 9, that is negative 3. But remember, it is under magnitude. Over square root of 16 plus 1, that is 17. And 17 plus 9, that is root of 26. So thereafter, the answer becomes 3 out of root of 26 units. And that becomes the distance between our plane and our line. As we had seen that these two are pair, so once they are pair, we have gone on to find that the distance between this plane and this line gives us root of 3 over root of 26 units. Thank you so much. I remain Alan Samuel Fuller. Please subscribe to our channel, and that is Tower Academic, for more videos. Thank you.